Good morning, everyone. So today's workshop is going to be on the topic of compound measure. So our intent of our workshop today is to look at calculating rates of pay, calculating speed, distance and time, calculating mass density, volume, and then completing some problem questions. So the first thing that we are going to look at on one of our compound measures is what we know of rates of pay. So rates of pay is what we see on our wage slips or what we calculate to work out how much we are paid for the jobs that we do. When calculating rates of pay, we can do our daily pay. So we do our hours per day multiplied by our hourly pay, which tells us what our daily pay is. Our daily pay multiplied by our days work tells us how much we're on per week. And to calculate our monthly pay, we can do hours per day multiplied by our hourly pay and then multiplied by the days in the month. And then to calculate our yearly pay, we do our weekly pay multiplied by 52. And that's all the calculations that we can do to work out either a problem question about rates of pay or even calculating our own rates of pay. So sometimes we can be paid what's known as overtime at a different rate to our usual pay. This is often written and said as a fraction like time and a half, so 1 and 1/2, or time and a quarter, like 1 and 1/4. So to calculate overtime pay per hour, you turn the fraction into a decimal and then multiply it by the hourly pay. So for example, if someone was paid £9.50 per hour, but on 1 and 1/2, so time and a half for their overtime pay would be, so we turn that 1 1/2 into a decimal, which is 1.5, and then we're multiplying it by the original hourly pay, which tells us that this person is now on £14.25 per hour for their overtime. So multiplying this by their standard rate will give you your overtime pay. So let's have a look at these now on our calculator. So calculate Sally's weekly pay if she works 6 hours per day at £11.50 per hour and works 6 days a week. So firstly, we've got to work out her daily pay. So to work out her daily pay, we're going to do the hours that she's worked multiplied how much she's on per hour. So 6 times £11.50. So her daily pay is going to be £69 a day. Then, to work out her weekly pay, we work out her daily pay by the amount of days that she works. So we know she's on, sorry, that's supposed to say 69, is on £69 per day multiplied by 6, which tells us she's on £414 a week. And that is how we work out weekly pay. So Mark works 30 hours per week. So let's highlight the word 30 hours per week. And he's paid £10.50 per hour. On a Saturday, he's on 1 1/4 multiplied by his normal rate. If he works 5 hours extra on a Saturday, what is his weekly pay? So here we have a rates of pay problem question. But what we've done, as we've read the question, we've highlighted the important parts. So we know Mark is on 30 hours per week and paid £10 per hour for each hour that he works. So to work out his pay from Monday to Friday, we do his hours multiplied by his pay. So we can do hours, which is £30 per week. So 30 multiplied by £10.50, which gives us 30 multiplied by £10.50. And he's on £315 just for his work Monday to Friday. Then to work out his Saturday, we need to find out his normal rate. So to work out his Saturday rate, it tells us in the question what to do. 1 1/4 times his normal rate. So we need to convert 1 1/4 to a decimal. So we know that the 1 will go before the decimal point and 1/4 is 0.25. So 1.25 times his normal rate, which is £10.50. So 1.25 times £10.50 is then £13.125. So remember it's pounds and pence, so we want 2 decimal places. So he's on £13.13. How many hours does he work on that Saturday for that overtime? Well, he works 5. So to work out his Saturday rate, we're going to do £13.13 times by 5 is then £65.65. So then to work out his total, we need his Monday to Friday salary, which is £3.15. Add on his Saturday salary, which is £65.65, and he is on £380.65 per week. And that is rates of pay. Okay. Our next compound measure that we are going to look at is calculating speed, distance, and time. Now, these triangles can be used for both speed, distance, time and mass density volume. And after this session, not only will you be given a worksheet, but you will actually be given revision cards in these 2 areas as well to help you with calculating those and remembering those triangles. So when calculating distance, speed and time, we can use the triangles on the right to help us remember the formula. So to calculate speed, we do distance divided by time. To calculate distance, we do speed times time, and to calculate time, we do distance divided by speed. And these calculations can help us work out journey times, correct speed limits, and how long a journey may be. In your calculations, however, your units of time should always be in hours. So to convert hours to minutes, we multiply by 60, and to convert minutes to hours, we divide by 60. So for example, say a question said a journey took 2.14 hours. This does not mean 2 hours and 14 minutes. It means 2 hours and 0.14 of an hour. So what we do is we multiply that by 60 to get our minutes, which is 8. So 2.14 hours is 2 hours and actually 8 minutes, not 14. So some calculations to now have a go at. What is 3.25 hours in hours and minutes? And what is 4.35 hours in hours and minutes? And what is 70 minutes in hours? So give yourself a few minutes to have a go at those. A key point to remember as well is that the number before the decimal is the amount of full hours that you've got. Let's have a look at some of these. So what is 3.25 hours in hours and minutes? So we know the 3 is 3 full hours, and then we've got 0.25 of an hour. So to get that to minutes, we're going to times that by 60, which is 15. So 3.25 hours is 3 hours and 15 minutes. Then we've got 4.35 hours in hours and minutes. So we've got 4 full hours and 0.35 times 60, which is then 21 minutes. So 4.35 hours is actually 4 hours and 21 minutes, and then 70 minutes in an hour. So what we've got here is how many minutes are in an hour. We know is 60. There's 10 minutes left from 60 to 70. So we've got 1 full hour and 10 minutes. And that is how we calculate conversions of time with minutes and hours. So now let's use this to answer some questions. So a truck travels 110 miles in 2 hours. What is the average speed? So what we've got to do is we've got to draw our triangle. D at the top, distance, speed, and time. What is the average speed? So now our question is looking for speed, so we've got to do a distance divided by time. Let's have a look at what our distance is in the question. So our distance is 110 miles divided by our time, which is in hours, which is 2. So to work out our speed, 110 divided by 2, and it's 55 miles per hour. Okay, Next question. Gustavo is driving a bus along a motorway with a speed limit of 70 miles per hour. In 30 minutes, he travels 36 miles. Is his average speed during this period exceeding the speed limits? Now we've got a problem question. Now the question is asking, is he travelling at a less or more or exactly 70 miles per hour? So we need to draw our triangle again. It's really super good to draw the triangles each time you do these questions. And your question is asking for speed again and the limit. So we're going to do distance divided by time. Now, our distance we know is 36 miles, but our time is 30 minutes. So we need to convert to hours by dividing by 60. So 30 divided by 60 is 0.5. So now we're going to do 36 divided by 0.5, and our answer is 72 miles per hour. So is his average speed exceeding, so that's going more than the speed limit? Yes, it is, and he's going above it by 2 miles per hour. So yes, he is exceeding by 2 miles per hour. And then our last one. Ian travels from Manchester to York. The journey is 60 miles. He travels 40 miles at 50 miles per hour, and he does the rest of the journey at 55 miles per hour. How long did the journey take? So here we're going to have to do the calculation in two parts. So first, how long did the journey take? We are looking for time. So now we're going to have to do distance divided by speed. So part one of the journey, we're going to have to do, he travels 40 miles at 50 miles per hour. So we're going to do 40 divided by 50. So let's pop that into our calculator. 40 divided by 50 gives us 0.8. So it's 0.8 hours. And then the rest of the journey, well, if he's travelled 40 and the total journey is 60, then he must have done the rest of the journey, which is 20 miles per hour, at the speed of 55. So 20 divided by 55 is then 0.36 hours. So then we're going to add these two up. So we're going to do 0.8 add 0.36, which gives us 0.8 add 0.36 gives us 1.16 hours. So then it's going to be 1 hour and then 0.16 times 60. It's really important not to do 60 minutes, which is 9.6 minutes. So we can say 1 hour and 10 minutes. Time up. We would not get the mark for 9 minutes because it's over that 9-minute threshold. Okay, so 1 hour and 10 minutes. And that is calculating distance, speed and time. Our last compound measure now is what we call mass density and volume, and it runs off the same premise as distance, speed and time. So we've got our triangles again. So when calculating mass density and volume, we can use the triangles on the right to help us remember the formula. So to calculate density, we do mass divided by volume. To calculate mass, we do density times volume. And to do volume, we do mass divided by density. And these calculations can help us work out the weights of objects, how much an object can hold and how compact an object is. Sometimes, however, the volume of the object might be missing when you need it for a calculation. If it is, you calculate volume as you would what we call a cuboid cuboid. So you do the length times the width times the depth. So you multiply 3 numbers together. And those numbers that you're multiplying will be given to you in question. So, for example, an ice cube has a length of 2 centimetres, therefore what would its volume be? So we know a cube has all the same size. Therefore, the 3 numbers that we're going to be multiplying together, 2 is the length, 2 is the width, and 2 is the depth. So 2 times 2 times 2 is 8 centimetres cubed, and that's always going to be our measurements for volume. So if a volume is missing, you might need to calculate it where you do the 3 measurements together. So let's have a look at these. So we're going to write out our triangle. So mass, density, volume. Jennifer wants the accurate measurements for the sandpit she wants to build for the EYFS room. The sandpit has a mass of 1,500 grams and a density of 2.4 grams per meters cubed. How much sand can the sandpit hold? So here we're looking for volume. So we're going to do mass divided by density. So our mass is 1,500 and our density is 2.54. We're going to pop that into our calculator and gives us 590.55 centimetres. Oh, sorry, it is meters there. Meters cubed. Brilliant. Okay, then a glass cube has a side length of 5 centimetres and a mass of 306.25 grams. Calculate the density. So here we're going to draw our triangle again, mass, density, volume, and here we want density. So we're going to do mass divided by volume. So here we have got a mass, but we don't have that volume. So as mentioned before, we do have a measurement of that cube. So to work out its volume, we're going to do 5 multiplied by 5 multiplied by 5, because it's length times width times depth, which gives us 125 centimetres cubed. So we're going to do 306.25 divided by 125. Pop that into our calculator. It's so much easier when you remember those triangles. They are really going to be a godsend in your exam. 306.25 divided by 125 gives us 2.45. And because we've got grams, so we say grams per, and then because we've got centimetres cubed, and that is our answer. Let's put little boxes around the answer so it's super clear when you read these back. Then, a solid silver spoon has a mass of 65.1 grams. The volume of the spoon is 6.2 centimetres cubed. Calculate the density. So we're going to draw our triangle again, mass, density, volume. We are looking for density, so we're going to do mass divided by volume. And then we're going to do 65.1 divided by 6.2. Pop that into our calculator. And we are given 10.5. What's our unit of mass? Grams. We use the word per. What's our unit of volume? Centimetres cubed. And we've got our answer. So that is all the calculations that you need to work out compound measure. What we're now going to have a look at is we're now going to have a look at problem questions. So Mr. Dixon is building a toy boat for children in the nursery. He has 3 different planks of wood to choose from. If wood has a density under 1 gram per centimetre cubed, it will float. Which plank of wood is the most suitable? So first, remember your units. So you have to deal in grams and you have to deal in centimetres cubed. If the measurements of in the question are not the same as an answer that it's asking for, you need to convert. So let's have a go now at plank A. But the first thing we're going to do, we're going to write out our mass, density, volume triangle. So we are looking for density. So we're going to do the density of plank A, plank B, and plank C. So we know density is mass divided by volume. So let's do plank A first. So our mass is 900 grams, and we're going to divide that by 750, which then gives us 900 divided by 750 gives us 1.2 grams per centimetre cubed. Okay, plank A is a little bit funny. Then we've got plank B. So now we're going to do density, so mass equals mass divided by volume. But as you can see, the mass is in kilograms. So how do we get from kilograms to grams? We're going to times by 1,000. So 7.6 times by 1,000 equals 7,600. So now our mass is 7,600. And we're going to divide that by our volume. But our volume is in meters cubed. Now, when we're converting from meters cubed to centimeters cubed, it's a little bit different than converting from meters to centimeters, because what you need to do here, you need to multiply by 100 3 times because you're cubing it. So you've done it 3 times. So we're going to go 0.0152 multiplied by 100, multiplied by 100, multiplied by 100. Right, we're going to do that in stages now. So 0.0152 times by 100, then times it by 100, then times it by 100, and we're left with 15,200 centimeters cubed. So let's pop that in, 15,200, which gives us 7,600 divided by 15,200, and that gives us 0.5 grams per centimeters cubed, and that's Planck B. And then our last one for Planck C is density divided by equals mass divided by volume. So our mass, oh, we've got kilograms again, so we need to convert to grams by timesing by 1,000. So we've got 1,020 grams. 1,020 divided by 1,000 centimeters. Let's give that a go. 1,020 divided by 1,000 gives us 1.02 grams per centimeter cubed. So then, if the wood has a density under 1 gram per centimeter cubed, it will float. Which plank of wood? So that won't, because it's not under. This one will, because it's under 1, but then this one won't, because it's not. So we would say Planck B is our answer. Okay. Then, our next one. Isabel is loading granite tiles onto her trailer that can carry up to 600 kilograms. Each tile measures 30 by 30 by 2.5 centimeters. The density of the granite is 2.5 grams per centimeter cubed. Isabel says she can place 100 tiles in the trailer. Is she correct? Explain your answer. So this is the mass. So she can carry 600 grams of mass. We need to find out the mass of the tiles and if she can carry 100. So we have our density, but we don't have a volume, but we can work it out. So we're going to use our triangle. We know to work out mass, we're going to do density times volume. So density times volume. Right. Now each tile is 30 by 30 by 2.5. So we can now work out the volume of the tiles by doing 30 times 30 times 2.5, which gives us 30 times 30 times 2.5 gives us 2,250 grams, centimeters cubed. So now mass density is going to be 2.7 multiplied by 2,250, and that's going to tell us how many grams each tile is. 2, 7. Each gram, each one is 6,075 grams. Now, Isabella says she can place 100 tiles in her trailer. And this is in 600 kilograms, but we only have this in grams now. So what we've got to do to work out if she can hold 100, we need to work out how many of this 6,000 grams can fit into that 600 kilograms. But remember, we've got 600 kilograms and not 600 grams. So we need to multiply that by 1,000. So we need to convert the kilogram into grams. So we multiply by 1,000. So 600 multiplied by 1,000. 600 multiplied by 1,000 is 600,000 grams. And then we need to work out how many tiles can fit, because we know each one is 6,000. So we're going to do 600,000 divided by 6,075, and let's see how many fit. And 98.7 tiles or 98 tiles. So Isabella says she can place 100 tiles. Is she correct? No, it will only hold 98. And that is our compound measure with rates of pay, speed, distance, time, and density, mass and volume. So now you'll be given revision cards in these 3 areas and a worksheet to complete.